Tonight I'm building a H-Bridge motor controller for my gripper. Okay, so if you saw my last video, I competed in the RoboCup Junior Rescue Line Opens Division, the New South Wales state competition, and I got third place.
The level is just too advanced, the bezel is Tiffany stamp, don't grip on my hand. I know that I came with the slide from left to right, but now
I am now going to the national competition, which is, the stakes are pretty high, so it's like, I paid like 1,500 and I'm traveling by plane to cross states, which is pretty cool. So there's a lot of pressure, you know, I gotta make this robot good. Now the reason why in states I got third place and not first place was because my gripper system, my lift and gripper system was unreliable. In this video, we're gonna be tackling the gripper system problem. Currently, my gripper system is in absolute shambles. It doesn't work for a number of reasons. I gotta find new ways to drive this motor, this gripper motor, and have it be very reliable, very robust, and I gotta make it pretty quickly because this competition is coming very quickly. As the brains of my robot, I'm using an Arduino Uno, and this gripper motor does not have a inbuilt motor driver board, so we're gonna make one ourselves. Thanks to this video on H-Bridges and the Art of Electronics textbook, I can design and prototype a working driver board that I can use in this robot. Now the circuit on screen right now is called a H-Bridge motor controller, and when this pin is high, the motor spins this way, and when the other pin is high, the motor spins the other way. And then I can easily hook these pins up to the Arduino and have the Arduino control which way the motor is spinning. Now for these purposes, I don't need any kind of fancy PWM or any kind of fancy speed controllers, but you know, I can always do it if I really want to. But as of now, I just need an open and a closed, and if it's at the same rate, I think that should be fine. Now I talked about this problem to my engineering teacher, and he let me borrow one of the motor driver circuit boards, and honestly, I don't think I'm gonna use it. Now if I develop my own versus if I use that one is probably better and more efficient, but the thing is that the part number is really faint and I can't really read it. So I can't really find a data sheet on it. And I'm actually engineering for the worst case possible. And worst case scenario, that motor driver breaks, but then I didn't design it, so I don't know how it works. But if the worst case scenario is applied to a board that I made and prototyped by myself, then I know how it works, so then I can just easily fix it, I guess. Yeah, so now I've just built the motor driver board, and here it is. Honestly, it doesn't look too bad. I'm using a couple MOSFETs that I bought from J-Car. You know, it's not too shabby. Could be better, but, you know, given the time frame, which is like 2 hours, you know, I think I did pretty well. Now the moment of truth to see if it works. I'm going to hook it up to my Arduino now, and let's see if it works. Wow, so how did that look? Very obviously that was a reenactment of what actually happened. Should be pretty obvious since the smoke was coming from the bottom of the board and not from the MOSFETs themselves. But yeah, I tested my board and then it started smoking real bad. I didn't catch it on camera, obviously. I guess I can take this as a learning lesson. So basically the lesson is to test your connections as you go with the multimeter and make sure that every part works before you actually do the first test. And also watch out for loose wires and big solder blobs to limit your chances of the circuit board short-circuiting. So what happens now? I fried 2 of my P-channel MOSFETs. Actually, I'm really not bothered to make myself a new H-Bridge motor controller because I actually have a better solution that will take a lot less time, and that's just to use this board. Earlier on in the video, I mentioned about not using a certain board because I couldn't find the data sheet for it. This is a different board. This is another H-Bridge motor controller that I got from my school's robotics lab, and it's a fairly common part, so finding data sheets won't be too hard for it. And also, since it's so common, they should have more of them in the robotics lab, so I could just bring them to the competition. If this one just happens to break, I can always just swap it out. Now, the reason why I didn't use this board was because it is, as you can see, very physically large. That means that I'll have to change around some of the Fusion 360 models. It's a bit of a hassle, but it should be fine. Okay, now, so finally, here's a video of how the H-Bridge motor controller is actually supposed to work. And also, by the way, I'm using an Arduino Uno, and the purpose of that is it's just turning a pin on and off and another pin on and off, so it can send signals via the control pin of H-Bridge motor controller board. Bros, some of these phrases are really hard to pronounce. And that's about it, man. Originally, I was actually not gonna post this video because I thought there wasn't gonna be enough content for a full video. But I guess since my board started smoking, it was a pretty good learning lesson, so I do have enough content. So this video is probably gonna go live. The next video, I'm actually tackling 2 problems: the 3D model design and also the power systems. This video should come out on the 18th of September. I'm just saying that for the accountability, so I don't slack off. It should come out on the 18th. Watch my last video if you haven't. It's like the video on the state competition. It's pretty cool. But you know what? Yeah, that's about it. All right. Thanks for watching. Thanks for your time. All right. See ya.